Thank you so much. I am incredibly honored that I was elected to this very, very distinguished group of people. It's just an incredible feeling to be among such talented and thoughtful human beings from around the world, really. Let me tell you just a little bit about myself. I have been interested in chemistry for many years. I trained as a physical chemist, but I decided that I really would be more interested in chemistry happening on a planet instead of a test tube when I found out as an undergraduate, actually, that such things as atmospheric chemistry were fields of study. So I did my graduate work. I got my degree at University of California at Berkeley in chemistry, working mainly with Harold Johnston, but Harold was a very good friend and close colleague of Paul Crutzen, who we remembered earlier today. So I managed to get a scholarship to go to the National Center for Atmospheric Research in Boulder, where he was director of the chemistry division. And I actually worked with Paul on my PhD thesis. I was, in fact, Paul's last American graduate student, and Paul Crutzen has a tremendous place in my heart. So I was so happy to hear that beautiful reminiscence of Paul. We miss him very much. What fascinates me is is how chemistry impacts our atmosphere, and particularly the sensitivity of the ozone layer to our human activities. When I was 29 years old, the British Antarctic Survey discovered the Antarctic ozone hole. It was a huge shock to the ozone science community. We expected to see a few percent change in 100 years, and instead we were seeing almost half the ozone layer being gone now. So of course there was a large amount of debate about what might be the cause, whether it was natural or due to chlorofluorocarbons, which were expected to do something, but as I said, about 100 years in the future and not at that time. So at the age of 30, I became the head project scientist of the National Ozone Expedition, which went to McMurdo Station, Antarctica. And with a team of 16 scientists, we made some of the first measurements that actually showed that chlorofluorocarbons were indeed the cause of the ozone hole. It was a transformative personal experience to go to the Antarctic. If you ever have the chance to go, I really recommend it. It's unbelievable. It's not a place, it's an obsession because it's so beautiful. It's so much the last place on Earth, the most untouched place on Earth. And yet we've managed to produce this hole in the ozone layer above Antarctica, which of course, as you probably all know, the ozone layer protects life on the planet's surface from otherwise damaging ultraviolet, which we didn't have the ozone layer life as we know it could not exist on this planet. I think it's fair to say that I came up with the chemical mechanism that produces the ozone hole. It involves the interplay of chlorofluorocarbons from chlorine from chlorofluorocarbons with polar stratospheric clouds, which form in the extreme cold of the Antarctic. So I made many measurements there for a period of years. I've actually been to the Antarctic 7 times. But science moves on, and nowadays satellites are able to do many of the same things that we did by hand and do it, frankly, a lot better and a lot faster. So now I analyze satellite data and I do numerical modeling, not just of the ozone layer, but also of climate change. I was lucky to become the co-chair of the Intergovernmental Panel on Climate Change, IPCC, the science panel, and led the process together with Qin Dahu of China that produced the 2007 IPCC report. So I had a chance to work with the policymakers and learn a lot more about climate change. Our report came up with the language warming is unequivocal, which I'm particularly proud of. Much of my career was spent at NOAA and as an adjunct professor at the University of Colorado. I also had students. I love teaching. So 11 years ago, I became a professor at MIT. I'm now the Lee and Geraldine Martin Chair there, and I continue to do both teaching and research involving ozone depletion and climate change. I'm particularly interested right now in the atmospheric chemistry of wildfire smoke, which, as you know, is becoming a bigger and bigger problem in many places around the world. I think it's going to be one of the huge issues of coming decades. So again, thank you very much for electing me, and I was honored to be there in July for the resilience workshop, which was a tremendous experience, and I'm very sorry I can't be there today, but thank you for giving me the chance to talk a little bit about my background.